Welcome to chapter 2. We're going to go into scalars and vector in this chapter. So I'll be introducing to you on force vectors, vector operation and addition of coplanar forces. So the objective would be student will be able to resolve the 2D vector into components, add the 2D vectors into Cartesian vector notation. Okay, let's look at some application of vector addition. Like example here, there is a hook here, and then there is three cables, or what do you call this, chains. So if you decide that if the hook will fail or not, what do? You need to actually combine into a resultant force and then convert the force to this hook here. So the force here will determine what type of hook to be used, what thickness, and what kind of material to be used. So the basic for this subject is actually to calculate the force. So the thickness and the type of material will come in your other engineering higher paper, which is like mechanics of material and also material science. So scalar, what is the difference between scalar and vector? Scalar examples is like mass and volume, vectors, force and velocity. So if you see the difference here, the scalars only have magnitude, whereas the vectors will have magnitude and direction. So the addition rule, this will be very simple arithmetics, whereas this you cannot add just simply like that. You need to use parallelogram or you need to use the vector calculations itself. So let's look at this. Let's look at the next slide. Okay, look at vector. It's very unique. A vector, the arrow and the direction will represent the vector. So if this is A with a length of, let's say, 5 cm, so 2A will be at the length of 10 cm. So it is very it actually uses the ratio method. The length represents the unit of the vector itself. So even the angle is very sensitive. So if you see here, if this angle is 30 degrees, so this angle will also be 30 degrees. The direction matters. So direction towards upward here is positive, whereas direction down here is negative. And look at this. This is 1.5 cm. So what would this be? Right? Guess the length. So it would be 5 plus half of the 5, right? So this would be 7.5 cm. And in the opposite direction, negative. Whereas 0.5a will be representing 2.5 cm. So this is just an example that I'm giving you. The value can be anything. So this is vector, very sensitive with the direction and also the magnitude. Now how to add this vector? There are two ways to go about it. One is the parallelogram method or the triangle method. We are actually in chapter 2.2 of your textbook itself, which is the vector operation. So we're going to look at how to operate the vector. So in a parallelogram, what you do is that this is your original drawing, right? So you try to join them. Like example like this, you put the A and then you bring the B closer. But of course, when you join them, you must remember to maintain the angle. Let's say this is 30 and if this is 20, you must maintain the angle when you move them. You can move anywhere you want, but you must maintain the length and the angle. It is very sensitive. So look at this now. You have joined them. After you join them, you draw another line here which is parallel to B and another line here which is parallel to A. Okay, so once you have done that, I'm going to use another ink. If you see, there is a flow already. Can you see the flow? A, and then B. So this would be A plus B. Okay, so A plus B, this would be the resultant. So this is the drawing method. Drawing method. Parallelogram. And same as triangle method, there is similarity, but it's just that you don't draw extra lines. You shift the A. Because it's A plus B. So the arrow of A has to join with the arrow of B. So you rearrange the B in a way that it will form a flow. Can you see the flow? A and B. Okay, so you will have A plus B. Of course, there is another option that you can also rearrange, and it's very sensitive because the direction matters. Now let's look at this example here. Can you see the B is flowing towards the A? So this will not be A plus B, but it will be B plus A. Okay, so these are the things that you need to know. Now, how do you subtract vectors? You subtract vectors by rearranging the arrow. Okay, so if let's say B is in this direction is positive, so B in this direction will be negative. So you use the same method, but you rearrange them. Okay, you rearrange, so you get A minus B. Okay, so that is how it's being done. Okay, next would be on resolution of vector, where you break up the vector into components. Yeah. Okay, let me just check the textbook. We are in resolution. We're going to go into addition, which is 2.3 from the textbook. Okay, let's go back to the resolution. So in resolution, yeah, what you do is that you combine the vectors. Yeah, you combine the you break up the vectors. Sorry, you split the vectors. So what you have here is F. Just now you looked at combining. So now we're going to split the vectors. Yeah. So if you see here, you have F here. So you need to split them into Fx and Fy. So in this case, we don't use Fx, Fy because the axis is called Fu and Fv. So it will be Fu, Fv. Yeah. So can you see it also forms another flow. So keeping this resultant. Yeah, keeping the same resultant, because the resultant in this question is actually in this direction, right? So you keep the resultant, you split them, okay, you will see a flow, which is Fu plus Fv. Okay, so next chapter would be 2.3 from your textbook, page 20. Yeah, page 20 from your textbook. So we're going to look at vector addition. Okay, so in vector addition, we resolve the vector into x and y component to continue the previous lesson. So you have a resultant, you break it up into fx and fy. Just now fu was not a standard angle, yeah, so it's a bit easy to a bit difficult to deal with that. So this is a bit easier, you see, because fx and fy. Yeah, now remember your I and J represents the unit vector, just shows the direction of the axis. Yeah, so what we have here is that how do you break it, how do you resolve it into x-axis and y-axis. Okay, let's say we have an angle here and the angle is 30 degrees. Let's see. Yeah, now remember from your sine and cos example, yeah, where you have your sine. What is sine? Sine is opposite over hypotenuse, right? And then you have your tangent. What is your tangent? Opposite over adjacent. And then we have the cos, which is adjacent over hypotenuse. So all this comes from the triangle. So if you have the angle here 30, okay, so this would be what? Opposite. This would be adjacent. This would be hypotenuse, right? Okay, you know that, right? You have done that in your school before. Okay, now we have our fourth resultant, which is F up here, right? This is your resultant. Okay, okay, so how do you represent this 30? The 30 would be sine 30, which is opposite over resultant, right? So what is opposite? What is this? Which in this case would be Fy. Yeah, opposite is Fy, right? Okay, so we have Fy. So what is Fy now? Fy will be, yeah, Fy opposite. Yeah? Opposite Fy will be resultant multiply sine 30. Yeah, resultant multiply sine 30. So this is how you find your Fy. So similar method you use actually for your Fx. Okay, let's look at Fx. Fx is down here, right? Okay, so Fx is cos, isn't it? Adjacent. Adjacent over hypotenuse. So Fx equals to adjacent, which is A adjacent over Fx is adjacent. Yeah, sorry. Okay, let me just erase this. Okay, let me just repeat that. Okay, which means cos 30. Cos 30 is adjacent over hypotenuse, adjacent over hypotenuse, which is in this case would be fx over resultant. So which means fx would be r cos 30. Can you understand that? Yeah, fx would be r cos 30. Okay, like for my students, what I do is that I always teach them shortcut method. Okay, whatever that angle, whatever that you need to find, yeah, you take the f, you close your armpit. Yeah, like you close your armpit, right? When you drop this would be the resultant that you need to find, fx. Probably it's a bit confusing for you, the concept, yeah, but it's okay. You just stick to what you have studied in your physics and in your maths, yeah. This is very, very important, the trigonometry, yeah. To summarize all this, it will be fx, yeah, fx would be f, resultant, they call f, cos 30, and fy will be sine. Opposite always will be sine. So f sine 30. Okay, so you stick to that. So this is how, this is another example. Okay, when it's in vector form, you can always represent it by I plus j, but of course you cannot plus numerical that way, yeah, because this is totally an 90 degrees 90 degrees apart from the j. So this I and j is just unit vector to show the direction. So you can also leave your answer this way. It also represents the vector. Okay. So now addition of several vectors. Let's look from your textbook, still at 2.3, yeah, 2.3 of your textbook before we enter example 2.1. Okay. So what we have here is that, okay, you see, you resolve it, yeah. F1, you drop 30. Let's say the angle here is 30. So how do you get this? This will be F1. Let's look at the next slide. I think they're given the angle here. Okay. Oh, they didn't give. They just showed you the resolving. Huh? So can you see F1? F1 is broken up into F1x, F1y. Yeah. F3 is broken up into F3x, F3y. And then F2 is broken up into F2x and F2y. So now you put all your F's together. Yeah, all your X together. And then you put all your Y's together. Okay. So you finally reduce it to your resultant of X, which is in I direction. Resultant of Y in J direction. Okay. Finally, you can summarize it. So how do you summarize it? Angle will always be y over x, yeah. Angle will be y over x. Remember your tangent. So what is your tangent? Tangent is adjacent, opposite, right? This is hypotenuse, right? So what is tangent? Tangent is, tangent of theta will be opposite over a, correct? So in this case, what is the opposite? FRY over FRX, yeah. So that's how you find your tangent. Okay, resultant, you use your Pythagoras theorem, yeah, which is FRY square plus FRX square inverse square root. You get the resultant. So this is how you actually solve the question. There are few examples in the slides itself, which I'm not going to go through. Yeah, I'm going to go through more difficult question from the textbook itself. Yeah, so before we move into the next chapter, let's just look at the question in the textbook. So this is actually from your textbook, page 23, if you're using the same edition as mine. So let's look at this. Okay, so what's given to you, the question is actually 150, and then we have 100, F100 at an angle of 15 here, and this is at an angle of 10. So we need to resolve, they actually finding for resultant force. So you need to resolve this all in y direction and x direction. Okay, remember what we have actually learned earlier. So here we need to drop it down to x direction and y direction for 100, to form x direction and y direction, and then for the 150 we also need to form x direction and y direction. So this is actually using parallelogram method, drawing method. Yeah, we can also use numerical calculations to solve this, but since that they are using parallelogram method, let's stick to that. Yeah, okay. So what we have here now, okay, you remember from your previous lesson your cosine law. Okay, now let me just open the textbook to remind you of what you have done with your cosine law. Okay, remember your cosine law? You have done this in maths before, right? Yeah, cosine law, you have done this in maths before. Remember? Okay, cosine, and we have the sine law. Okay, now going back to the example, so if you see the example now, okay, this is actually applying your cosine law. Okay, it's using trigonometry method to actually find all the angles, and then you can resolve it. Okay, so now rearranging the vector. Yeah, rearranging the vector. This is the original. We have 10 degrees here, and then we have 15 degrees here. So what is the angle in between? It will be 90 minus with 25. How do you get 25? The 15 and the 10. So the angle in between will be 65. Yeah, 65 here. The opposite will also be 65. You remember that? Yeah, you studied that in your what do you call? In your maths before, right? Okay, so what will the angle here be? Remember your trigonometry? It will be 360, which is in a closed box will be 360 minus with 2 times of 65. Yeah, 2 times of 65, because one triangle is 180, so we have 2 triangles, we have 360 minus with 2 times 65. So where is the 65? The angle here. So if this is 65, this is 65. So what do you have the balance? So that's why it is 115. So you mean this angle here is now 115. Okay. Now redrawing the whole thing, I will be having like this. 115 here. I've got 65 as the phi inside here. I have 150 here and I have 100 here. Okay. So what is the force resultant? Remember your cosine law. Okay, going back to the textbook, remember this law here? We have C. So C would be what? It always the angle, yeah? The angle here would be the opposite, would be the C. Here would be the B. Yeah, and here would be the A. Of course, you can rearrange anything. But what I'm trying to say is that the arm here, the opposite will be the same angle. You have to refer to the same formula. Okay. Now going back to this, using your cosine, what we have here? We have 100 square plus 150 square. Yeah. 100 square plus 150 square minus 200, 150, and the angle for your force resultant, the opposite angle will be 115. Okay, so you solve using your calculator, you get the resultant as 213. Now you applying the sine law. So what is the sine law? You remember the sine law? The sine law will say A over sine A is equals to B over sine B, equals to C divided by sine C. So it's a standard formula. So if you have two angles that you know, like example this one, you know the resultant, you know the angle, so you can find the missing angle. So that is your sine law. So with that, you can find the phi. Okay, so we have the theta, which is 39.8, plus with the phi, which is 15. 15, where did the 15 come from? Remember from the question, the 15 is actually here. Okay, so with that, you get the total angle as, it means this whole force resultant to the x-axis will be 54.8 degrees. Okay, so this is the first part of the chapter. I will see you in the next chapter. So you can actually solve example 2.2, 2.3, example 2.4, yeah, and I will meet you again for chapter addition of system of coplanar forces. Thank you.